So now let's discuss the different types of spring. Okay, there are different classification of springs. The very first one is helical spring. So as you can see, this is a helical spring, and this one is a compression helical spring, and this is a tension helical spring. In tension helical spring, we have these two hooks. So obviously, these springs are put into say some other hook for loading. So you can see in both ends there will be some hook for loading. So what really happens when you put the load at this point? Okay, when you apply the load, give a load at this point, guess what? Obviously, it's will elongate, right? So that's why it is called tension helical spring. The spring would enlarge. Okay, won't enlarge, and there would be spatial distance between the uh, helical spring ring. This is a tension helical spring, but here it is a compression helical spring. Load will be acting from the upward, so it would compress. Okay, it would be compressing. Okay, this is the case of compression helical spring. Okay, so this is a tension helical spring. It would enlarge because we are applying load. This part would be hooked to some point, and then the load will be applied by some means of hooking in this part. So obviously, this will elongate. There will be spatial distance between the spring, and this is a compression spring. We are simply applying a load on the top of it. So it would compress, so the spatial distance between the compression helical spring decreases. So this is the two major categories of helical spring, and as you can see, this is of helical shape, right? These two springs are of helical arrangement. Okay, so this is simply all about helical spring and the two classification helical spring. And the load types of load applying in helical springs are compressive or tensile loads. And the cross section, uh, there are different types of cross section. It would be in general in helical structure, but even though the cross section or the shape of the each spring wire would be different. It could be either, if you take the cross section, it could be either circular, square, or rectangular. Okay. When do you call the helical spring to be close coil? When the spring wire is so close to each other, right? When the spring wire is coiled to so close that the plane contains each turn is nearly at right angle to the axis of the helix. So we'll be having two turn. So there are different so many turns of spring. So if you take the plane of each turn, it would be almost 90 degree to the axis of the spring. Okay, that's the condition when a helical spring is said to be close coil. That means it's stacked so together such that each plane, the plane containing each turn would be 90 degree to the axis of the spring. Okay, so or you can say the helix angle would be very small when it is close coil. That means it would be almost less than 10 degree. And the major stress produced in the helical spring, obviously, if you apply, even if it's a compression or tensile, there would be stress developed inside the spring, and the major stress developed in the helical spring is the shear stress, and this due to twisting of the wire spring. Because shear stress is the major stress in the helical spring. The load applied could be either, you can see it could be along the axis of the spring or parallel. In the case of open coil spring, the spring wire is coiled such a way there is a gap between the two consecutive turn. As a result, just the opposite of a closely coiled, the helix angle will be large, so the application is limited. We won't be using open coil helical spring too much because we will be only using the closed coil. That's having a very large application. Here, the compression helical spring is an open coil spring. Why? There's a gap between the each springs. But in the case of tensile helical spring, it is closed coil because there is no gap between the springs. When it is loaded condition, it would be having gap, and compression spring would won't be having any gap between the. But the non-loading condition, we are defining the nature of a spring. So the open coil spring is compression and the closed coil is tension. But large application will be using the helical springs are having a very large application, and the major one will be using the closed coil. So the open coil function is very much limited. Okay, so we'll be using closed coil spring very widely, and some of these following advantage of the helical spring in general are they are easy to manufacture, they're widely it is easily available in wide range, and they are reliable. It will last at a very large time and they have a constant spring rate. So the major advantages of helical spring. So these are the first category of spring, helical spring.